Hello class. Today we are going to be covering a topic in high school algebra, specifically how to write expressions in equivalent forms to solve problems. We're going to be looking at 3 questions along with an extension problem. So let's begin. Now let's recall, how do we read quadratic equations? Well, the standard form for a quadratic equation is ax squared plus bx plus c is equal to 0, where a, b, and c are all constants, so they're numbers, and we want to make sure that our right side of the equation is 0 before solving. Now, taking a look at this equation, we have x squared plus 3x minus 10. So our a is going to be 1, our b is going to be 3, and our c is going to be negative 10. So now that we know how to read the quadratic equations, let's go ahead and start with our second example. So now we have to solve for x squared minus 10x plus 15 is equal to negative 6 using the factoring method. So let me ask you guys a question. Is this equation in the standard form right now? So this equation is not in standard form right now because we don't have a 0 on the right side. So let's go ahead and fix that. We can add 6 to both sides and we get x squared minus 10x plus 21 is equal to 0. All right, now this is in standard form. We can go ahead and begin our process. So listing out all the constants, we have a is equal to 1, b is equal to negative 10, and c is equal to 21. Now we want to look at c specifically here, and we want to make sure that we list out all the factors of 21, and with those factors we're going to be able to add them together to get our b. So listing out our factors, we have 1 and 21, we have negative 1 and negative 21, we have 3 and 7, we also have negative 3 and negative 7. So we want to add these factors to where it gets us our b, which is negative 10. And which of these pairs is going to be added to negative 10? It'll be negative 3 and negative 7, sorry. So negative 3 and negative 7 will be our factors. So we can go ahead and set up our factored form of the equation where we have x on both factors, and we can simply insert our factors. So right after the x, so we have x minus 3 times x minus 7. Now it's important to have the 0 here at the other side because we can set both factors equal to 0 and we can solve for our x's now. So our x is going to be 3 and our x is going to be 7. And let me show you why it is. So when we could set each factor equal to 0, because when we plug in both factors to our original factored form, let's plug in 3 first. So we have, this is our original factored form. When we plug in 3, it gives us, all right, let me go ahead and fix that. It gives us 3 minus 3 times 3 minus 7, which is going to be 0 times negative 4, which is equal to 0. So that'll be true. Now, plugging in our second factor, 7, we get 7 minus 3 times 7 minus 7, and that'll just be 4 times 0, which is just 0. So this checks out. That's why we're able to separate them, because whatever factor you plug in, it'll result in a 0 regardless. 0 times something, whether it's 0 times negative 4 or 0 times 4. All right, let's go ahead and move on. So I want you guys to try this equation. Now, you're going to solve for x with the equation x squared minus 7x minus 22 is equal to negative 4. So go ahead and try this. I'll give you guys a minute. All right. Now, first we want to set this in standard form, so we get x squared minus 7x minus 18 is equal to 0. I'm going to list out our factors of negative 18, so it's negative 1 and 18, 1, negative 18, negative 2, 9, 2, negative 9, negative 3, 6, and 3, negative 6. Now, the factors that will add up to negative 7 will be 2 and minus 9. So when we go ahead and set this up, it'll be x plus 2, x minus 9 is equal to 0. Plug in, or sorry, we're going to set each factor equal to 0. And then we get x is equal to negative 2 and x is equal to 9. So that'll be the solution. All right. Now let's go on to the extension. So take a look at this equation. 2x squared plus 3x minus 2 is equal to 0. What's different about this equation, and how would you approach this? Now in this case, right, it's a little bit different. I want you guys to think, how would you approach it, right? I will go over this in class tomorrow, but for now, think about your process, think about what ideas you may have, and bring it to me tomorrow. All right. I'll see you guys later. Have a good one.